Welcome to Smart Software, a podcast where we talk about best practices in web and mobile software development with a focus on new and emerging technologies. My name is Justice Ethan, and I'll be your host today. I'm a developer at Smart Logic, a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. From the Smart Logic team today, we have myself, Justice, and the birthday boy, Eric Ostrich. How old are you today, Eric?
Yesterday as of recording, but I am in a new decade, I will say.
Okay, well, at least it's not a new century. So Eric and I have been working on season 2 of Smart Software, and season 2 is centered around Elixir Internals. So we've been talking about the inner workings of popular Elixir libraries, and today, we are joined by a contributor to a very interesting library. His name is Dave Lucia, and he's joining us from New York City. And I'm actually in his office right now in One Penn Plaza. You work for SimpleBet. Dave Lucia, do you want to say hello and introduce yourself?
Yeah, so hello, I'm Dave Lucia. It's really nice to be on the show. Thank you guys for having me. I am a contributor to Rustler, although I don't want to put so much emphasis on that because my contributions are very minor compared to those that started that package, which is really amazing, by the way. Did you want me to give a little background on myself?
Yes, I want to hear a little bit about yourself because this is the first time we've done a guest interview in person.
Oh, wow.
So I'm in New York City right now. Eric is remote still, but I'm sitting in the same room as Dave. We're in your office. So if you could tell us a little bit about yourself, but also the company that you work for.
Yeah, wonderful. And actually, it should be mentioned that we almost had Eric with us, but due to a flight mishap, we couldn't get him here in the flesh. So
non-Elixir related technical difficulties.
Yes, that's right. Yes. So the weather was not on our side, unfortunately. Right. It's hard to program around that. Okay. So yeah, just to repeat, I'm Dave Lucia. I'm VP of Engineering here at SimpleBet. We're doing a lot of really interesting work in the sports betting space. The sports betting industry is quite old. Mm-hmm. It goes back, like some of the companies that are still active go back to 1863. There's a lot of job services that were written in 1863 as well that are still active. Sorry to all of those who have heard that joke too many times. So what we're trying to do is build innovative, engaging user experiences for sports bettors. And when we went to go do that initially, when our CEO started out, he was looking for someone who can provide them the odds of the markets that he was looking to build. So markets like who's going to score next in the next 5 minutes of this game, or for the NFL, will this drive result in a touchdown? Is Tom Brady going to throw an interception this drive? And so when he went to go find a provider to get the odds for the markets, like the probability of an interception being thrown is X and the probability of a touchdown is Y. There was no one who could do that for those types of in-game markets. And so what we realized is we should be the provider of those odds. And what we're doing is we're building an application that ingests real-time data and uses a bank of historical information and produces in real time those odds using Elixir and Rust.
And this is like the perfect use case for Elixir.
Yeah, it's actually amazing. Elixir and the Beam VM and Erlang are so good at concurrency.
Right.
And when you're dealing with sports, you're dealing with potentially a dozen odd baseball games at once, plus whatever other sports are in season. Concurrently managing all of those sports is really important, and it's really important to get it so that if one sport has an issue, one event has an issue, the other one doesn't go down.
Got it. And before we jump into some of these like open source questions, talking about Rustler, maybe you just want to tell us a little bit about how you personally got started with Elixir.
Absolutely. Yeah. I started out my career at Bloomberg, and I was doing C++ for a long time, which was fun, but a little bit hairy. And then I moved over to Bloomberg.com and was part of the 2014 Bloomberg.com relaunch, doing a lot of JavaScript. And my manager at the time, he really got me into Elixir. He was, formerly really big on Ruby, found Elixir some way through the Ruby ecosystem, and he got me really fascinated with it. I started building Slack bots, and all of a sudden I wanted to build everything in Elixir, and I was trying to really push that hard internally, but it wasn't quite in the books. This guy, Josh Topolsky, he was formerly of The Verge and Vox Media. He started his own company called theoutline.com, and I had met him through Bloomberg. and they were looking for an Elixir developer. And so I joined as the first developer reporting to the CTO. And so we built a online magazine, so a really visually engaging news media experience. So we built a content management system and the front end for that website, all in Elixir from the ground up.
And it is a really, really beautiful website. I was going to save these questions for toward the end, but I think it's okay if we talk about the outline now. Can you tell us a little bit about like how the outline was running Elixir and what the architecture looked like?
Absolutely. Most websites today, or at least a lot of the engaging user experience typed websites, use single page app frameworks. React gets thrown around a lot. People love Vue. Maybe people are still using vanilla JavaScript in some cases for single page app experiences. What we try to do is we try to leverage Phoenix's server-side rendering capabilities, which I think get less love in the community than they should. It's really easy to spin up a server-rendered website and then add JavaScript on top of it to give it more of those, dynamic features that make it, more interesting to engage with. So on mobile, the outline, you can swipe through articles like you would on like Snapchat, swiping left and right, and it feels very nice. That's JavaScript that is on top of a server-rendered page. We're able to render pages in microseconds in some cases, and we are serving millions of users a month with no CDN caches of pages. Every single user was hitting the server, and we were doing that with only 2 Heroku dynos, with really not a lot of effort put into making it performant. Just out of the box, Elixir did that really, really well.
Eric, can you give any context around how amazing that is?
So I guess mostly coming from a Ruby experience, if you were to try and get away with that with 2 dynos, you'd probably have the performance L's and then just fill up those dynos with as many Puma workers as you could. So it's just pretty incredible to hear. We've heard another company on this podcast, I think last season, Kava had a single dyno and was serving all of their restaurants. And it's always amazing to hear Elixir on Heroku and the memory just sits at a flat 100 megs and it's just barely doing anything, even though you're serving a lot of requests. So it's pretty great.
Yeah. And actually something to add. So we added a feature somewhere down the road where we actually spun up a process per user who went on the site. And then as they navigated around the site, we were basically an event log of how they were interacting, which posts they were seeing, so that we could do things make sure if they seen posts 1 that they didn't see it again when they came back. And so when we first launched that feature, I was really afraid that it was going to be this giant memory leak and go through the roof. And the incline was definitely there, but it really didn't matter. And we leveraged the fact that every day the Heroku dynos turn over. And so that would be our memory reset, and then users would come back and restart their process. And, what was really cool about that is you get kind of the best of both worlds, where you're holding application state in memory, but you don't really have to worry about losing it. It's not that important of information. We call it the semi-stateful application.
All right, so let's switch over to some open source stuff. So looking at your GitHub profile, you've been pretty active in just a smattering of Elixir projects. So you want to tell us how you got involved with that?
Yeah, absolutely. My contributions have definitely been small, although I wish that I, had time to do more. I got interested in open source through a project called Hackety Hack when I was back in college. So probably around 2009, 2010. This guy, Steve Klabnik, who's actually really big in the Rust community now. He had this Ruby project that was intended for teaching other people Ruby. And I actually never ended up contributing to it, but it became a fascination of mine to be a part of those communities who, focus on projects like this. And so I always had that desire to be part of the open source community, just because I found it so great, the way that people can collaborate and build really interesting software. I think actually it started out when I was in Bloomberg. I started contributing to a few Node.js projects, libxml.js or something like that being one of them. But as I've joined the Elixir community, the community is so great, and I follow GitHub issues all the time and see where I can add my contribution. And I've helped out with some documentation efforts and small bug fixing in Elixir itself. I was interested in helping out with the Elixir Slack project, Floki, which is an XML project that we used very heavily at the outline. I added some features to that. And then most recently, Rustler, I added some features that made error handling a lot better error messages, so that when you're transferring state in between Elixir and Rust, you can really know what's going wrong when you hit a certain edge case.
What is your process for finding issues and resolving them? Are there any tips you would give for someone looking to get involved?
Yeah, I think the best way to start is just, if there is a project that you really like and you're really excited about it, just start following it on GitHub. And then, every day or once a week or whatever works for you, just follow the issues that are coming into the project, follow the pull requests, like get a pulse on what's happening, and then look for gaps in documentation. That's always, I think, the best place to start is find places where you can make the project more clear for everyone. Elixir has, I think, world-class documentation, not just in terms of like the quality of what's out there, but also the XDoc, the system for delivering documentation is quite excellent. So start there if you're intimidated, but look for opportunities where, there's something where you'd like in that project that you don't see something that you think should be there, and, try and add it.
I want to double down on this advice that you're giving because, first of all, I think this is a common question that beginner programmers have is like, how do I get involved with open source? And I think that they should go look at your GitHub profile because you've contributed to Elixir, you contributed to Phoenix, you contributed to Rustler, so you contributed to these major ecosystem components, and they're not like massive PRs that you were submitting, but they help move the project forward. And you're a VP of engineering at a pretty successful startup here, so it's indicative of the approach that someone should or can take and be successful in open source. Eric, do you have any more open source questions before we move to the specifics?
Yeah, so we like asking everyone if your employers have helped with your contributions to open source. So did the outline or your current employer, SimpleBet, help with contributing to open source?
To some extent, yes. And I think, here at SimpleBet, I want to do more. Part of it is like having stability in the product that you're building so that you can, justify giving back and making time for open source. With that being said, a lot of times the justification for working on open source could be, hey, we use this open source project at work and we need this feature. And that's actually what happened with Rustler, where we were running into issues where we were trying to get better introspection into what was happening when we had an error happen. And so I just added features to, make error messages a lot more verbose and explicit. Ivar Vong, who's my boss at the outline and a good friend, he encouraged me to, make time and when appropriate, work on open source. But, here at SimpleBet, I want to take that a step further. And, as we, have a bit more stability in our product, I really want to make actually explicit time where people can work on side projects and open source and give back to the community, because I think, that doesn't just benefit the community, but it also raises your profile externally. Giving those contributions, you get to see, other people get to see that SimpleBet or the outline or Smart Logic is giving back to open source, that they're doing interesting things. And then it's also a really good recruiting tool in some ways. People see those contributions and are like, oh, maybe that's a good place to work.
So my next question here was how you got started with contributing to Rustler. It sounds like, is that what you were just describing with the error handling?
Yes. Maybe to just dive into it a little bit more.
Please do, yeah.
So we work really extensively with Elixir and Rust. And there's this concept called native implemented function in the Beam VM, which is a way to connect C native code and use it to execute in the Beam VM. So the Beam VM is really good at concurrency. It's really good at fault tolerance and high availability, but it's not known for number crunching, for executing instructions at a very high speed. And so when you need that, you can leverage this NIF interface, native implemented functions, and write C code that you can leverage existing libraries or write your own code to get really high performance. Now, Rustler is a library that allows you to do that, but with Rust code and have all of the safety guarantees of Rust. So for those who don't know too much about Rust, Rust is a systems level programming language. It's designed as sort of a successor to more of a C++ than a C, but definitely both. And one of the main goals of the language is to make it so that you can't shoot yourself in the foot. The language is safe as long as you write safe code. Unsafe code, on the other hand, is code that you explicitly mark, you wrap it in an unsafe block, and you get, some of the compiler restrictions get turned off for you. You can do certain types of pointer arithmetic and stuff that can lead to those fatal null pointer exceptions, segfault, if you will. And so with Rust, you really have a really big safety net for that. And that's why there's a really good candidate to write these NIFs in. The other flip side is that NIFs, if they're running too long, can interact with the scheduler in a negative way. So you have to be careful about that.
Mm-hmm. So you just described what NIFs are, but what are you using NIFs for at SimpleBet? And you're writing these in Rust and they're compiling down to C, right?
Yeah, so they don't compile down to C. They compile down directly into machine code. Okay. So they get compiled into assembly and get compiled into a binary executable, or actually a shared object that gets linked into the Beam VM. So what do we use it for at SimpleBet? So we're building this pricing engine, right? Let's say you have a market like the money line. Is team A going to win? Is team B going to win? Or is it going to be a tie? And so we want to assign probabilities to each of those selections. And so as we're coordinating that state on our Elixir code, and we're keeping track of real-time incidents that are coming through from our feeds, we then take the state of the game and we want to run them through our models. As I mentioned, Elixir is not so great at the number crunching, and that's what these machine learning models that we write are all about, is doing a bunch of math really, really quickly. And so we call an Elixir function, which is actually Rust behind the scenes, and it could turn over those pricing in microseconds or single-digit milliseconds. And so we're re-implementing our models in Rust, and that allows for really high turnover time.
So can you talk a little bit about like the challenges? I mean, you have the best perspective on this of almost anyone I know, but you're running so many languages in your backend. Like, can you talk a little bit about the challenges of doing that?
The challenges of having multiple languages in your backend?
Rust and Elixir, and you've got Python going on, so and probably maybe things I don't know about. So
yeah, we use secret language X as well.
What is that? What am I left out?
Yeah, so we're using a little bit of JavaScript too, but yeah, you hit the nail on the head with Python, Elixir, Rust. All these languages have different strong suits. I mean, Python's really good at interfacing with all these scientific and mathematical libraries. NumPy, scikit-learn. Basically, every data scientist toolkit is usually Python, or if you're really nerdy, you're using like R or Julia or something like that. For the most part, our data science team uses Python, and it's really good at doing research and running multiple models and backtesting and all the things that our data science team does. And then our Elixir and Rust team, they're working on building that production system that then takes those models and makes them go fast, turns it into a real product. But I think the challenge within all of that is that these are all of the very different skill sets, right? And finding a way for the people who have these different skill sets to interact is really important. To get everyone in the room and to be speaking the same language is really important. So one of the things that I did early on in SimpleBet was, for our machine learning models, I was just trying to get up to speed with, I'm not a data scientist and I didn't fully understand the work that they were doing. And so I, established a common vernacular that we use to describe, this type of work in these machine learning pipelines. We now have very explicit language that, both the engineers and the data scientists understand, so that we can speak the same language and, have objective conversations. But going more specifically into the languages itself, we're doing a little bit of like cross-pollination, where some people who maybe know Python are learning Rust. The people who know Rust, because we're exposing that in Elixir, they're learning some Elixir. Some of our front-end engineers who are writing React, we're teaching them, they know JavaScript, we're teaching them Elixir. And so that cross-pollination is, I think, really important, because it gets people, one, exposed to new ideas and maybe informs, if I learn something about Elixir and functional programming, maybe I'll write better JavaScript.
Right.
So I think that's really important. And I don't know if I answered your question, but happy to dive into that a bit more.
Well, I also kind of want to circle back a little bit to Rustler, because so Rustler it's a Rust to Elixir bridge. Is that right? So it's sort of providing the framework for these natively implemented functions to run in Elixir. Now, you contributed to Rustler. Can you talk a little bit about like what Rustler is doing on a technical level?
Absolutely. Yeah. So Rustler is divided into a number of different crates. Crates is just the word that they like to use in the Rust community for a library. Mm-hmm. So of the crates, off the top of my head, there's the Rustler core, which is like when I'm writing my Rust code, that's the package I import to define my interface, define the functions that I want to export as Elixir functions, right? So typically when you're writing a Rust NIF, there's some, boilerplate code that you use to define, hey, I have this function with this many arguments and I want to expose it. And so you expose those functions, you write those functions and, delegate to whatever code you want to write. And that's using the main Rustler package, which is purely a Rust package. But then there's Rustler code gen, which you don't typically interact with directly outside of some decorator macros. So for example, let's say I have an Elixir struct, right? My struct's name is smart logic. And I want to expose that. It's got a few fields on it. And so I want to expose that in Elixir, that struct, but I want to be able to send that through to Rust code. And so what you do is you write a struct in Rust that has matching field names. And then you annotate it and you say, module, this is an Elixir struct, and module is, and then you name out the full Elixir module. So elixir.smartlogic. And I'm actually pretty sure you can omit the elixir dot as well. And then so what will happen is Rustler code gen will then generate the code for doing the serialization, deserialization between Elixir and Rust. So all you have to do is call some term .serialize, and you specify in the left hand of the operation the struct that you want to deserialize it into, and then that generated code will make sure that you've have all the right fields and that the types that you annotated for each field are correct. Actually, this is the part that I contributed to. So it used to be that if you had a struct in Elixir, right, and let's say you had two fields, one was called num and the other was called string, and respectively, there's supposed to be a number and a string. Right. And if you passed in a string for the number field and vice versa, Rust would just return an error, NIF error, which is obviously not very useful.
Right.
And so my contribution was actually to print out the struct and the field that was incorrect and give you a pretty decent explanation as to what was going wrong. Now, going back more into like what is a part of Rustler, so there's the main package, Rustler, there's Rustler code gen, which generates like the binding interface. Then there's Rustler mix, which is the Elixir compiler, which knows that you're in a NIF, and it delegates out to the Rust up binary, which will actually compile your Rust code and put it in the right place for the Elixir VM. I think that is mostly everything. There's actually another interesting package that I think was created off of a issue I added to Rustler, which is Rustler CERD, which is a serialization, deserialization library that makes it even easier to do the thing I was just talking about.
I just want to point out, because I looked up the GitHub repo for Rustler while you were talking about this, and because I can just imagine this error situation that you were describing being so frustrating. I wanted to know how many people you were like potentially helping by solving that problem. And there's like 1,500 stars, so I'm sure a lot of developers are very grateful to you for implementing that error handling code.
That'd be cool.
They should reach out to Dave Lucia and let him know how grateful they are.
I'm very grateful for, I actually don't know the names. I think it's like Hanshi. Man, there's two people who are like the biggest contributors to Rustler. And it's a big thank you to them actually for the ingenuity they had to even start that project. And there's a lot of really interesting work that has gone into that project. So, I mean, I'm very proud of my little contribution, but I mean, all of the big thanks goes to that crew who have, built that package and have maintained it over the last few years and built a really high quality piece of software that so many people use.
Well, we were going to talk a little bit about comparing Rust to Elixir, Maybe we can go there just a little bit. Can you talk about maybe some of the salient differences? They seem like very different languages to me, but I'm no expert in Rust, so I'd love to hear your perspective on it.
So I was actually asked to write a blog post on this.
Did you?
No, I've been so busy.
Before we started this podcast, we were all lamenting how our marketing people want us to write blog posts, and we just push them off. And they love us for it, of course.
So I've written only 3 blog posts. 2 of them were pretty decently successful, but I've been wanting to write about, people have written a decent amount about Elixir and Rust and, how, you can combine them. But I actually wanted to talk about like how they're a perfect pair, but also how they are conceptually similar at the surface level and how that makes learning, one way versus the other, at least syntactically, a familiar experience. So, Rust and Elixir, both languages, were really inspired by many languages that came before. I think if you asked anyone who contributed to Rust and was involved, with any of the design of Rust, they would tell you handfuls of languages where they really just, took ideas and made it part of Rust. And I think the same goes for Elixir. So the blog post I wanted to write was just, describing how I think it was the dream stack is what I wanted to call it. But it's like, for our use case of really wanting the concurrency of Elixir and the number crunching of Rust, having both and combining them together has been such a wonderful experience. And using Rustler as a library makes that really, really easy. And then I wanted to talk about, at a surface level, things like pattern matching is very, very similar. There's a case statement in Elixir, there's a match statement in Rust, and they work almost identically. There's actually some extra features that you get in Rust because of the type system that make it even more interesting in some cases. And the other way around, because Elixir isn't typed, you can do some other types of more powerful matching that is just maybe a little bit less restrictive than what you would have to do in Rust. And so, there's a lot of functional concepts and, surface level things like pattern matching that you have in both languages that if you jump from one to the other, you're like, oh, it's quite familiar. That's nice.
Yeah.
And what would you say would be a good spot to start learning Rust if you're interested in making your functions way faster?
Well, first of all, I want to just point out a package to watch out for, which is the creator of Rustler. Oh my God. Eric is showcasing something, which I'm going to say in a moment, but there's this really interesting package out there that's being started by the creator of Rustler. All you do is you just annotate your Elixir function and you say, I want this to go fast. And then it actually generates a NIF for you based on the Elixir code you write. I don't remember the name of it off the top of my head. And
a functionally equivalent NIF, or is it just like a
yes.
placeholder NIF? No way.
That's
yes.
really cool. Nifty?
Yes, Nifty. I think it's pretty experimental right now, but it's quite interesting and quite aspirational. And I'm really curious where that goes.
That's amazing.
So keep an eye on that. I don't want to blow up their spot if they're trying to keep that package quiet, but I've been following a little bit and it's quite interesting. The best way to learn Rust and the way I learned Rust is the Rust programming language by my hackety hack friend, Steve Klabnik. So that book, I read it front to back and I bought the hardcover just like Eric did, but I actually read the entire book online. The whole book is available for free online and I really encourage you to buy the hardcover. If not just to keep it on your desk as a little token, but to also support the authors. It's a really great book. I learned a lot from it, and there's so many community resources for diving into further topics. The Rust Playground is really a great online tool for experimenting with Rust code and just testing things out. And then there's some better resources that are popping up, like interactive learning experiences online, of which I don't remember the names of any. So sorry for not being more prepared, but I'll see if I can get those over for show notes.
We've deviated really far from our script today, which is sometimes
that was my goal.
The case. Well, you've succeeded. But I want to ask a question because it kind of occurred to me, is there anything that you've learned from doing data science, machine learning models in Rust? Is there anything that you've learned about sort of the process of coming up with the model in a theoretical sense and then coding it and then writing it in Rust? Is there anything that you've learned there that people who are working with data scientists and data engineers to sort of make this whole thing work that would be helpful to them?
Yes, you should come apply to SimpleBet and find out what it's like firsthand. That's all I'll say.
Eric, do you have any other questions before I give him time to shamelessly plug SimpleBet like he just did?
I think I just want one more, I guess, statement. I just want to point out that Rust has a tool called Cargo, which is very similar to Mix in Elixir, and it's just as nice as Mix, but for Rust. So I've done a little bit of Rust and like kind of playing around with it, and like finding out that they have a really great build tool and like package tool kind of built all in one really helps doing compiled code that's like C and C++. Then like no one knows how to figure out make files and like auto conf and all that fun stuff. So it's a lot easier to just give Rust a shot. So yeah, that's it.
Great.
Yeah, Rust seems very intimidating, just to add to that slightly. It's intimidating for a lot of people and the learning curve is high, but there's a lot of really great resources out there, and the compiler is so friendly. It basically tells you exactly what you've done wrong and points to additional information. So, don't be afraid to get your hands dirty and try it out.
And it has that really cool thing where it points at exactly the spot that's wrong with like a little ASCII art.
Yeah, it's great. I actually think that was taken from Elm, the Elm compiler, which is another really great piece of software.
Oh my gosh, if you name drop Elm, the people listening to this podcast will be so happy.
Oh man, I've written a decent amount of Elm. I built a tic-tac-toe game in Elm when I was interviewing a few years ago. That was really fun. Elm is a nice little language, although I'm not so sure about its, production level viability. Maybe other people can speak to that.
I think that's what it's so popular in the Elixir community, but I think that everybody sort of feels the same way about that particular hesitation. So Dave Lucia, do you have any final plugs, asks for the audience, directions to social media, where to find info in your library, your company, etc.?
Yeah. So again, I work for SimpleBet. Our website is simplebet.io. There's not a ton of information about us right now as we're gearing up to get our product into the market, but we're hiring Elixir developers, Rust developers, data engineers in Python, and some DevOps people. So if you want to be a part of a really interesting company that's trying to do some really cool and interesting things in the sports betting space, there will be a link to our Elixir job description in the show notes, and you could find the rest of our job descriptions through there. You can find me at DavyDog187 on Twitter. That's my 5th grade handle, and I will never get rid of it. Or dave@simplebet.io if you want to shoot me an email.
Great. Eric, any final words? He's shaking his head no. Dave Lucia, thank you so much for joining us today. Once again, this has been Smart Software with Smart Logic talking about Elixir Internals. Join us next time for more sweet, sweet alchemy.
Thanks for having me, guys.